All right, hello everyone. Hope you had a good day so far. Yeah, so I'm gonna talk about generative foundation models for music and sound and how we use them at Mirelo to bring your videos to life with video-aware audio generation. So to start, a little bit of background on me. So I'm Florian. I did a PhD here in Berlin in machine learning, and then spent 2 years at Google Brain afterwards as a researcher, then 2 years at AWS, and then decided to start something myself with a co-founder. And I'm also really into music, playing the guitar and piano. So I'm quite excited that I could actually combine my two passions about music and AI. And so we have a great team. So everything I'm gonna show you is like built by this amazing team. First of all, my co-founder CJ, who is also the CEO of our company, and all the other great people listed here. So what are we doing? I already said we're building generative models for music and sound. And with that, we aim to revolutionize how audio is created and used. Okay, that's like just a boilerplate sentence. So what does it mean? Imagine this scenario. So you just created a cool video, but now you want to add some sounds to it. And typically people use stock libraries, but often it feels very generic and everything sounds very similar and you cannot really personalize it to your own needs. And hiring musicians or composers is quite expensive and time consuming. And ideally there would be a way of trying ideas much quicker. And maybe we could use AI for that. So let's see. I mean, that's a cool video without any sound. So clearly something is missing. So let's see what we can do. Yeah, so that has been all generated automatically with our AI models. So let me tell you a little bit more on what we have under the hood. So we have models, or like a model that can generate music. So the input would be typically a text prompt and potentially some lyrics, and then our model will generate some music for you. So I will show you some examples. Is this actually playing? No.
The sense of magic in your eyes. When you fail, it's time that you pay. I kiss so passionately as we memorize.
So here the prompt has been great for parties, danceable rhythm, sophisticated production melody, and we also gave it some lyrics, and that was the output.
Sweet things you do sets my heart aglow, and
Okay, let's jump into some other examples. Also can create classical music. Okay, I mean we could listen to it forever, I guess, but let's jump ahead. Some jazz. Okay, and some background electronic vibes to chill. All right, that's some music. We also can generate sound effects and primarily synced to videos. So yeah, I want to show you a few examples. So like all these inputs were without any sounds, and we didn't give any text prompts to our model. We only told it to generate some sounds that would fit the video. Yeah, so what the model has to do, it has to semantically understand what's going on in the scene and then also to sync the audio perfectly to what's happening in the video, right? As you have seen with the skater, you really want that you get like these hits sounds when the skateboard is actually hitting the ground. So also some computer game stuff. Yeah, so you can go wild. So that's like some models we've trained and built over the last year, and we also have some offerings. Just in a nutshell, we have a web app, which I'm going to show you later, and we also have an API offering, where you can actually query our models, and we can also fine-tune our models on your data and for example, your music catalog, if you have something like that. Okay, I was told, that there's it's like a machine learning conference and not just a product pitch conference. So I want to also tell you a little bit about the tech under the hood. I mean, obviously, I can't go in all the details, but I want to give you like some quick, an idea of what's going on. So maybe just to calibrate myself, who of you already has played with some machine learning code? Okay, nice. Who of you already read a few machine learning papers in your life? Cool, and who actually trained a machine learning model? Also quite a bit. Cool, then I guess we can jump into some technical details. So I guess most of you know large language models, autoregressive transformers. I guess there were probably already some talks today, so just as a quick reminder, typically you have some text. Then the text is encoded into tokens. You can think of like the words or like chunks of these words are mapped to just numbers. Then these numbers are embedded and fed into the transformer. The output is a distribution over all these possible tokens, right? In this example, the second token has like the highest probability, and then you can choose some sampling scheme to actually sample a new token. In this case, we just select the token with the highest probability. And we can see what we get. So the most exciting conference for sure is the dida conference. And so now we can see how can we actually adapt this architecture to generate music. And it turns out you actually don't need so many changes. So, I mean, the first thing that needs to be changed is the input. It's not text anymore. Now it's audio. Also, the output should be something like an audio token or some chunk of audio. And additionally, we want to have another conditioning input to our model. So we don't want to just generate audio on its own sake. We also want to tell the model what to generate. So we have this additional text conditioning. For example, here we would say, give me some 90s techno. Cool, so how would we do that in this autoregressive generative manner? So we already have some audio tokens or an audio sequence. We would then encode them into tokens. Now it's a little bit different than before. Now each chunk doesn't get like only one token, but multiple ones. I explain it later. We often call them codebooks, so you can just view them as multi-dimensional tokens, basically. Then you would feed it into the LMM again, or into the transformer. Now you get a distribution of the tokens for each codebook. So before we only had one, now we have 3 in this example. Then again, we can sample a new token, and that can be decoded back into audio. So you can actually really see them as like audio chunks, basically. Okay, so let's dive into some details. So the first one we used was like these tokens. So that's like maybe looks a little bit complicated. I will explain it in a second. So we actually need to somehow encode these tokens, and for that we can do many different things. Like some prominent approach are variational autoencoders. What I'm showing here is based on encodec. And the idea is actually quite simple. Let me try this. Yeah, so basically you have like a typical encoder that maps your input to some lower dimensional representation. In audio, we like to use 1D convolutions, right? Because you want to somehow shrink your input sequence, and so we convolute it. Then we have some intermediate representation, and then we have a decoder that maps it back to the input. So then we have like a few complicated losses. I don't go into the details here. Basically, it's a combination of reconstruction losses and some perceptual losses. And so we train this whole architecture. And then there's another thing we need to add, because in our transformer, we actually need discrete tokens. And typically, a variational autoencoder would learn like a continuous latent representation. So we need to quantize it. And there's, again, different ways of doing it. Here we use something called residual vector quantization. So you basically just map the continuous representation to a few numbers. Here again, it's the same thing with just a nicer image. So yeah, encoder. Maybe one more time. Oops, that was the wrong button. Yeah, the encoder maps it to this residual tokens and then decodes it back to the audio. Okay, so we solved this part, and now we only need to solve the conditioning part. And that's also quite standard. You would also use something similar in image generative models. Is it? Now I'm confused, this button. Yes. So we have these tokens. We already discussed them. They are the input to our model. Then we have this additional conditioning input, the text, in this case a beautiful piano arpeggio. We embed this text with some standard language model. In this case, we use the T5 encoder. So it gives us like a continuous embedding of the text, and this is then just fed into the model. There's like different ways of how you could do it. In this case, we use cross-attention. So the audio tokens can actually attend to the text tokens and adapt themselves based on the user input. And then there's a last tiny change we have to do. Instead of just giving this one categorical probability distribution output, we have like one for each codebook, and we just use 4 different linear heads for that, mapping to softmax probabilities instead of one. So in a nutshell, we just did like a few changes to the original transformer architecture, and now we have a generative music model. Actually, not too hard. Cool. So what are we doing at Mirelo? So we are obviously building our own generative models. We both explore auto-regressive transformers, like techniques like what I just showed you, but we're also looking into diffusion models and flow matching models, and even combining these approaches, because both of them often have their advantages and disadvantages. For example, one thing we noticed is that auto-regressive transformers are often better to model long-term coherence in long sequences, and diffusion models are often better to model details in a local time frame. And so it's a natural next step to just combine it. And we're also very interested in including rich site information, like musical specifics, like genre, instruments, mood, and also videos, as we've seen before. We are also looking really seriously into training our own codecs, because they will, determine the quality of the outputs, the sound quality. So we have some codecs that have much higher audio quality over existing ones, and we make sure they both work on music and sound effects. And it's also important to us that they have a low sample rate, because you want to have a small number of tokens per 1 second of audio, because the shorter your sequences are, the better your models scale typically, right? I guess most of you probably heard that the main complexity of a transformer scales with the input sequence length. So we want to keep them short. And we both have continuous and discrete variants, because for transformers you need discrete tokens, but for diffusion models and flow matching you can actually use continuous representations, because you can model the generative process directly in the continuous space. Yeah, and the third important topic for us is flexible control. So you have already seen the video conditioning. That's a quite challenging thing, because you want to condition the output semantically on the video. You know, the model should know what's going on in the video, but you also need to sync it, because videos have this very clear temporal structure, and you somehow need to think about how to put this information into the model. And you want to have control over musical aspects, and be robust to different styles of prompts, you know, very detailed one like Japanese instrumental jazz from the 70s, but also very generic ones like romantic dinner music. All right, so with that, I want to show you a little bit how this looks in our product, which you actually can try yourself. If you want, you can just go to Mirelo AI and try it. So the first thing I want to show you is like a small demo widget we have directly on the landing page. That's for our sound generation. Let me see if that works. Yeah, okay, I don't know if you can see it. So here I'm just typing helicopter. I press generate. So this is only using the text now. And then I get to it. So got two examples. There's always some variance to it. So now I put dog barking. I even have a typo in here. I just realized it, but it still worked. Dog barking. Again, some variance. So the next feature is that you can use a video. You can either upload it or use one of our template videos. Is it playing? No. Yes, now it works. So I'm using just this video of someone running at the beach without any prompt. So the model is only using the video in this case. And again, there's some variance to it, right? You want to try different things and then select the one you like the best. And as a final example, you can also use additional text prompts to guide the model to focus on something specific. So I realized that the ocean waves were there, but not so loud. So I type in ocean waves to make them more prominent. And let's see if the model understands that. So yeah, ocean is a bit louder, and also the footsteps are a bit more water sound, like, you know, more muddier. And so for the final part, I also want to show you our full app. I recorded it because, I didn't, you know, it's like always stuff can go wrong. That's why I recorded it, but I just did it like right before coming here. So all right, so let's explore the full app. So you can go to the app here. For that you need to register, but you can do it after the talk if you're interested, and we will grant you access. Yeah, so that's the full app. So we can start with a video again, and this time I will upload something. I will just take this video here. It's like this random sword fighting video. I will mute the original audio because we want to generate the sounds ourselves. I can also zoom in a little bit. Okay, let's have a look. Okay. Quite some intense fighting going on. I go to this position here so we have more space. Yeah, I think we can start with some sounds. So first I go on this empty track here, and you can just select some, like a snippet, like some area I want to generate. Okay, and now I can select if I want to have sound or SFX, or if I want to generate music. Then I can tell the model, oops, I selected too much. So let's go back. Yeah, now I can tell the model if it should use the video or not. Before I moved it like too much to the right, so it just told me, okay, there's like some area where we don't have a video, so you can't use it. That's why I made sure the audio selection is within the range of the actual video. So I can tell the model it should use the video as an input, so it actually generates sounds that are synced to it. Or I can also turn it off and just type in some prompt here, or I can use both combined, and then the prompt is used as an additional guidance to the video. So let's try this combination, and I want to generate some SWOT sounds. Yeah, so I will give some. Will tell the model to fight to focus on the SWOT fighting, and I can press generate. Now it will generate two variants, two suggestions, and I can select one of them, or I can also regenerate if I'm not happy with it. Let's see what we get. Okay, sounds promising. Both quite intense, I would say. Let's just take the first one and let's see how it looks with the video. I think that's great. You can see like the SWOT sounds are perfectly synced. Yeah, I'm happy with it. Let's take it. And now I will just generate some music as well. I created like a new track with this plus. Now I have a track 2 here. Again, select some area. We'll take the whole video. And now I press music. And now our model already analyzed the video in the background, and it's suggesting us some ideas that could fit to the video, basically. So a dramatic score with building crescendos, an epic instrumental music, or intense heroic background music. I think that sounds all good. Maybe I will go with the epic instrumental music, but I can also type anything I want or like edit this suggestion and it will adapt it to the video. Okay, let's go with this one. Again, it will generate two variants. And I can see which of them I like most. So let's see what we get. All right, so now it's ready. Let's start playing the first one. I think that's already quite nice. Oh, maybe I like the second one more than like in the end there's like some orchestra coming in. So like this is very short, like only 6.5 seconds or so, you know, you can generate much longer music sequences. So would have been interesting to see where the orchestra is going, but okay, for the sake of the presentation, just take this short snippet and let's see how it looks together. Cool. I mean, sorry, I will just make the sword fighting a little bit less loud so we can hear the music better. Okay, I like it maybe a little bit less. Cool, let's go on. What else could we do? Maybe let's just add a new track. So now we can also add like additional sounds, maybe stuff that is even not in the video. So just for fun, I will add like in the middle of the video, I will add some wolf, for example. I guess it could fit the scene. Maybe in the background there's like a wolf. So let's try wolf how is it written? I think, sorry, I have to Google it. Wolf howling. Howling? just like that. So that's, see, it's not, not scripted. I do it live. Wolf howling. Cool. Let's see what we get. Cool. 2 variants again. Okay, it's a bit more like a dog, I would say. Let's just try it again. I mean, I think it's okay, but I think we could probably do better. Let's try it again. I mean, I could have taken the last one, but let's see. So I'm just showing you, you know, there's like always some variations. So sometimes it's interesting to see what you can get. Okay, this I like more. Okay, the second one is, yeah, both fine. I will just take the first one. Okay, so is it selected? Yes. Cool. Then let's have a final watch with the wolf. Okay, that's everything I wanted to show you for today. All right. Yeah, that's what I wanted to show. So I'm also happy to take some questions now. Also, I'm happy to get in touch after the talk. And please try the stuff. It's live now on our website. You can just go to Mirelo AI and try it yourself. And let us know how you like it.